This video will be on graphing sine and cosine functions. So for sine and cosine functions, there are 5 critical points. 0, pi over 2, which is also 90 degrees, with 0 equaling 0 degrees, and then pi, which is 180 degrees, 3 pi over 2, which is 270 degrees, and finally 2 pi, which is 360 degrees. These critical points are important because they help us to find the extrema and zeros on the graph of y equals cosine x and y equals sine x. So for cosine at 0 we know is 1, cosine at pi over 2 is 0, cosine at pi is negative 1, cosine at 3 pi over 2 is 0, and cosine at 2 pi is 1. So then we have the points of 0, 1, pi over 2, 0, and then pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. Now these points help us to graph. So we have a point at 0, 1, and then at pi over 2, 0, then pi, negative 1, and then 3 pi over 2, 0, and 2 pi, 1. And then that kind of pattern is going to repeat going rightward with 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi, and then in the negative direction with pi over 2, with negative pi over 2, negative pi, and so on and so forth. So thus we have the graph looking like this. We can see from the graph that y equals cosine x has even symmetry, meaning that the positive and negative versions of a radian, like negative pi over 2 and positive pi over 2, have the same y-coordinate, or the same cosine value of 0. Now let's do that same process with sine. We know that sine of 0, or at 0 degrees or 0 radians, is 0. Then sine at pi over 2 radians is 1. At 0, or at pi is 0. At 3 pi over 2 is negative 1. And at 2 pi is 0. So therefore we get the points of 0, 0, and then pi over 2, 1, and then pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. Now we can graph those points of 0, 0, pi over 2, 1, 0, or pi, 0, then 3 pi over 2, negative 1, and 2 pi, 0. And just like with cosine, the pattern repeats both in the positive direction and the negative direction. So you can graph it. There we go. Now we see from that graph that y equals sine of x has odd symmetry, meaning that the positive and negative versions of the same radian, like negative pi over 2 and pi over 2, have opposite y-coordinates, or opposite sine values, with sine of pi over 2 equaling 1, and sine of negative pi over 2, which is really sine of 3 pi over 2 equaling negative 1. We can also see from the graphs that a cosine graph and a sine graph are 90 degree or pi over 2 transformations to the left or to the right of each other. And this is shown with cosine of 0 equaling 1, with sine of pi over 2 equaling 1, showing how the graphs are pi over 2 transformations of each other. Now let's get into some basic definitions that are useful to know. A periodic function, like a sine or cosine function, is a function that repeats its output value in regular intervals called periods. A period is the horizontal length of one cycle. So we see that sine and cosine have a usual period of 360 degrees or 2 pi, with a min of negative 1 and a max of 1. Now what goes along with period is frequency, and the frequency of a periodic function is the number of cycles that the function completes in a given interval. The interval we use for sine and cosine graphs is the period. Therefore, the frequency equals the number of cycles over the given period, or 1 over 2 pi. We also know that the midline of a periodic function is the horizontal line halfway between the function's minimum and maximum values, with the usual midline being y equals 0. Because halfway between a max of 1 and a minimum of -1 is 0. Finally, we have the amplitude of a periodic function, which is half the distance between the function's minimum and maximum values, which can also be seen since midline is halfway between the minimum and maximum values. It will be the distance from the midline to the minimum value or the midline to the maximum value, with the amplitude of a y equals sine of x and y equals cosine of x graph being 1. And that is all you need to know for graphing sine and cosine functions.